Thanks, Belle. Thanks for the introduction, and thank you for everybody for tuning into this. I know if you're like me, I'd much rather be outside on a nice day like this, but we are all stuck inside for various reasons. So hopefully this will be a informative and somewhat entertaining hour or so, talking about one of my favorite subjects, invasive bark and ambrosia beetles. So with that, we'll get started. This first slide here is no surprise to anybody who's on this call. You all know how forest products and forest pests move around the world. Certainly the events of the past month or two have emphasized the interconnectivity of all the continents and how things and people move and everything across the globe. So again, no surprise here. Forest pests move in forest products as well as wood packing material. And I think this next slide to me was surprising when I first saw it, that bark and wood infesting insects get intercepted on wood products from 119 different countries. This is a USDA APHIS Port Information Network data from sort of a snapshot for about 15 or 20 years ago. But I think it shows just what a challenge it is to detect, identify, to understand where these things are coming from, what their potential impacts may be, because the bark beetle fauna from all these different countries is so diverse and so unique, and some of them are pests and some of them might not be. So you've all heard of all these various invasive wood-boring beetles. Certainly things like emerald ash borer, Asian longhorn beetle, to a lesser extent, maybe the Syracuse wood wasp on the lower left there, have gotten a lot of attention and have caused serious impacts across the U.S. Certainly emerald ash borer killing hundreds of millions of ash trees across the country. But as cool and as important those things are, bark beetles and ambrosia beetles are way cooler. And hopefully by the end of this hour, you'll appreciate those. I mean, even with names like the guy on the upper left, amputatus, or the one on the upper right, mutilatus, or the one in the middle with those cool spines and legs. These are all ambrosia beetles that some are here, some are not here, but anyway, way cooler than those other guys that we talked about. So bark and ambrosia beetles used to be a family of beetles. Now they're a subfamily of weevils, but they may occasionally slip and call them a family, but they are the most commonly intercepted family of beetles in the U.S. ports. And you see that ship there just bringing in all sorts of cargo. There may be solid wood packing material in those containers, and it's always been a challenge to detect and stop those beetles from coming in and then becoming established and spreading across the country. So we'll talk about that a little bit today. What I'd like to do in the next 45 minutes to an hour is talk a little bit about what bark and ambrosia beetles are, talk about some of the major ones that are here and having impact, and then just kind of a summary of what we can learn from all the ones that are here. Why are some of those important? Where are they coming from? So bark and ambrosia beetles, there's a lot of native species in the country. They cause a lot of mortality across our forests. I'll talk about those. And what we're going to talk about today, though, are some of these invasive species that have caused some serious impacts, not only in the rural native forest, but also in the urban environment. So what are bark beetles? We're talking about bark and ambrosia beetles. What are bark beetles? Well, these are some images of bark beetles. There's things like Ips on the upper left and Dendroctonus, like the mountain pine beetle on the right side there. So bark beetles, as the name implies, feed underneath the bark of trees. They bore through the bark, and when they hit that phloem cambial area, before they actually hit the xylem or the wood, they make their galleries. The gallery that's going longitudinally across there is made by the female. She lays her eggs along there, and those little lines that you see radiating from there are the mines that the larvae make. Eventually they turn into pupa and then adults, and then they bore out of those trees. So those are bark beetles, and maybe some of the more famous, if you will, are things like the southern pine beetle that has killed millions of pine trees across the south. You see the beetle on the left and one of the spots or infestations on the right side there in a pine stand. Certainly the galleries of southern pine beetle are very characteristic. Again, you see the winding galleries by the female, and then the larval mines by the developing larva. Quite often you'll see these pitch tubes like you see on the left. That's a sign that the beetle is attacking a healthy tree. The tree is trying to defend itself by creating that pitch. In the West, there's a somewhat similar beetle, same genus, the mountain pine beetle. And you can see there that graph on the right where maybe in the past decade, this beetle was killing or had acres with mortality over 8 or 9 million acres per year. And over this outbreak in the United States, there was probably 20 million acres with dead pine trees, and that was also the case in Canada, probably another 20 million acres in Canada. So mountain pine beetle and the spruce beetle, like you see pictures on the left there, that mortality, those are native bark beetles, again, attacking underneath the bark. Ambrosia beetles are somewhat different. They are the same group, the same family. There's not a particular taxon. There are several different groups of ambrosia beetles that have arisen independently within the subfamily of bark and ambrosia beetles. But one thing they all have in common is they carry with them an ambrosia fungus. They too bore through the bark, but they keep on going into the xylem. That picture on the upper left there, you see on the left side of that image where the beetle bores through the bark and it gets into the xylem. And you'll notice that that gallery is stained, and that staining is from the ambrosia fungus that they carry with them. That's what the beetles feed on. The adult feeds on it as well as the developing larvae. So you see those little side chambers off of there. So the beetles are not eating the wood. These ambrosia beetles don't eat the wood. They eat the fungus. So they don't have to make these big, long, winding galleries through the wood because they just need a little spot to grow the fungus and feed on that fungus. The staining that you see on the right side there, that image, again, that's caused by the fungus, and that often causes some degrade of the lumber, especially in the West. There's some native ambrosia beetles that are very serious pests of wood products out there. And just like bark beetles, the galleries are somewhat different with the different species or different genera of ambrosia beetles. The one on the lower left is a little bit more winding through the wood, but the same idea is that they are feeding on the fungus in the xylem because they cannot digest the xylem. They're just feeding on the fungus. Good example of this is on the left side there. You see the beetles, there's adults in there, there's larvae, there's pupa, and there's the fungus. Some of these beetles have developed this kind of fungus farming, and some of them have even developed into a semi-social habit where you may have 1 or 2 or more generations in the same gallery. This is a sort of a cave type of gallery where the siblings or the first generation remains in the tree and helps the parent tend that garden, maintain the fungus, and helps keep that gallery clean of the joys of working from home with the phone ringing in the background. Sorry about that. So yeah, they help tend that fungus and maintain the fungus in the galleries. The picture on the right there, you see there's wood sawdust or frass coming out of that gallery. Remember I showed you the picture before of the pitch coming out. Well, in this case, the beetles again going into the xylem, so you'll see this white. It's a kind of a mixture of beetle excrement as well as the wood fibers that it's kicking out. So it's white because the xylem is white. So that's an indication that there's ambrosia beetles in there, and they're in the xylem. And I'll also show some more pictures of that later. So bark and ambrosia beetles across the world, there's about 6,000 species, quite a diverse group, occur pretty much in every continent except Antarctica. A lot of diversity is in the tropics, especially of ambrosia beetles. There's a little less than 2,000 species of ambrosia beetles, and I would say the majority of those are in the tropics, old world tropics and new world tropics. In the US, we have about 560 or more species of these bark and ambrosia beetles. 75 of those are ambrosia beetles. And of those 560 species in the US, probably more than, I'd say now it's probably about 70 species are non-native. And of those non-native species, about 33 of those are ambrosia beetles. There is another group that I'm not going to talk about too much, the seed and twig infesting bark beetles. So they also make up about 20 or so of those non-native species. So between bark beetles, ambrosia beetles, and seed and twig infesting beetles, there's about 70 or so non-natives in the United States. Now, not all of those 70 are serious pests. In fact, most of them are not. They may be attacking dead, dying trees. Like I said, there's a number that just attack seeds, dead, dried up seeds or twigs. They're not really pests. So I would sort of cut it down to about a dozen or so species that I'd say have some impact on forest and shade trees. There may be some more occasionally, some may be problems, but then they kind of come and go. So for the next part of this talk, I'll talk about some of these that have had an impact and what they are, how they're moving around, and what the impacts have been, basically. So maybe one of the most famous ones is the European elm bark beetle. This is not a new species, obviously. This species has been here for probably at least 100 years. The Dutch elm disease fungus that this beetle vectors obviously causes the death of elms across the country, and elms were a really predominant tree on the landscape in the native forests as well as city streets. For those of us old enough to remember, the city streets lined with elms. These nice tree that you see on the right side of that picture on the left there turns into the dead and dying tree on the left side. I mentioned the ambrosia beetles carry fungus. Well, turns out that this beetle, even though it's a bark beetle, also vectors this fungus. It doesn't have any special association. It doesn't feed on the fungus. The fungus is just kind of a hitchhiker with this beetle. And when the beetle feeds on the twigs of a healthy tree, the fungus gets introduced. It then moves into the xylem or to the phloem of that tree, the conducting vessels, and it moves throughout the tree, and then it starts to die. And then that beetle, the next generation of beetles, will attack that and breed in that dead and dying tree. So again, not a new phenomenon. This beetle has been around for 100 years, and the Dutch elm disease fungus has been here for probably since the 1930s anyway. Another bark beetle that has gotten a lot of attention recently is the pine shoot beetle. This is a much more recent introduction, probably in the late 80s. It was found in 1992 in Ohio. It has really not lived up to its reputation, although it has caused some problems in Christmas tree plantations. It too feeds in the twigs or the shoots of healthy pine trees, and then the next generation or that generation goes to breed in the trunk of a weakened pine tree. It has not caused serious problems, like I said, although having that same habitat or habit of feeding in a healthy tree and then breeding in a dead, dying tree makes you think that, well, if it does pick up a fungus, it has the possibility of transmitting that fungus to a healthy tree. So something to watch out for. It hasn't done yet, and it may never do it, but that beetle fungus interaction is always something to keep an eye out for. So the rest of these beetles on the list, the ones that are underlined, are all ambrosia beetles, except for the one at the very bottom, Scolitis chevirui, the banded elm bark beetle, which I won't talk about. Very similar to the European elm bark beetle, but a much more recent introduction. But the rest of those are all ambrosia beetles, and I'll talk about most all of those in the next part of this presentation. Just real quickly, the first two of those, Anisandrus dispar especially, that's been here for probably 200 years or more. It was the first non-native bark beetle identified in this country back in the early 1800s. It occurs across the country, I think in most of the lower 48 states. It's not really a pest in the east, but interestingly, it seems to be a pest of fruit trees in the west. It's been here for a long time. It carries a fungus with it. But again, it's kind of in the background, causing some problems, especially in fruit trees. And the next one's Liberus saxacenae. I should say that a lot of these do not have common names, so sorry about all the scientific names here. That one too has been here for probably 150 years or more, and it occasionally causes problems in nursery stock. It hits weakened trees and stressed trees, and it may push some of those trees over the edge that may have normally recovered from the stress, such as flooding or drought, or newly transplanted nursery stock into a landscape. So the rest of these, like I said, I'll talk about a little bit more detail. In the southeast, if you go out in the woods and you see some trees that have these shoots, twigs that are dying, that's often caused by this black twig borer, which is an ambrosia beetle that is a little different in the sense that it bores into the twig and gets into the pith of the tree, and it makes its gallery into that pith of the twig, I should say. And that point of entry in that small twig that's only, probably less than a half an inch in diameter, that twig, where that beetle bores in, then breaks off, and you see these broken twigs along the stems of many different species of trees. One thing I should mention here is most of these ambrosia beetles do not have a preference, like a bark beetle may only attack a pine tree or a spruce tree or an elm tree. Ambrosia beetles are much more prolificous. They're just looking for some xylem to grow their fungus in. So they have a wide host range. And this beetle in particular, you'll see it in dogwood, you'll see it in maple, sweet gum, many different types of trees in the southeast. The other thing about this slide that I'll talk about a little bit more in detail later is the difference in size between females and males. As in most of these ambrosia beetles, at least in this tribe Xyliberinae, which is the ones I'll be talking about most, there's a lot of difference between the sexes. The males only have one set of chromosome. They do not fly, they don't have wings, and they stay in the gallery. So I'll talk about that a little bit more detail when I talk about some of these other ones, but keep that in mind when you think about how these beetles get moved around and how they could become established in an area so quickly. One that you may be familiar with is called the granulate ambrosia beetle. It used to be called the Asian ambrosia beetle, but then there were so many Asian ambrosia beetles, they had to give it a different name. It's called granulate because if you look at the back end of this beetle, you'll see this is called a declivity, and it almost looks like sandpaper. It has lots of different granules. It's very dull, and that's where it gets its common name. And you'll see that again, this beetle causes those frass tubes coming out of the tree. To me, that's an indication. Only a few of these ambrosia beetles do that, but have that where it sticks out together. To me, I think that's an indication that this tree is somewhat healthy and there's a lot of moisture still in that tree. And this beetle does attack stressed trees that still may have some green foliage on them. But again, it sort of pushes those trees over the edge. A lot of work has been done by a USDA research entomologist in Ohio, Chris Ranger, where he's looked at flooding and drought and how those things make these trees very susceptible to ambrosia beetles. And this is one of the species, along with another species in the same genus, that seems to be, I'd say, somewhat aggressive in attacking these trees. So how do they sense these trees that are being stressed? Well, it seems like these trees that are flooded or drought stressed produce ethanol, and these beetles really key in on ethanol. In fact, if you're sitting in the back having a beer or some other adult beverage right around now in the springtime, these beetles will often be flying around trying to get into your beer or glass of wine or whatever. They do like ethanol and very attracted to it. So that's a signal that there's something in that tree that's declining, and that's when they start attacking it. So one beetle, ambrosia beetle, that's got a lot more attention recently is the red bay ambrosia beetle. This is somewhat different than some of these other ambrosia beetles that I've been talking about in several ways. One is the fungus that it carries is much more pathogenic. Those other beetles and most other ambrosia beetle fungi do not seem pathogenic. The beetles introduce them to the galleries, the beetles feed on them, and the fungus really does not have too much of an impact on the tree. This is different. It's different in several ways. Like I said, not only does it carry this fungus, it also has a much more limited host range. Most ambrosia beetles are just looking for xylem, like I said. This one seems to have a preference for members of the laurel family, the Lauraceae. Red bay is a Lauraceae that occurs on the southeast coast, all the way from the Atlantic coast along the Gulf Coast. Kind of an understory tree. And you see on the right side there, the streaking that is an indication that this fungus is moving up and down the tree in the water conducting vessels or the xylem or phloem vessels of the tree. And that quickly plugs up the tree, and these trees die very quickly within a year. You'll see a tree that's been attacked by a red bay ambrosia beetle wilt and die very quickly. So the trees on the left are examples of those red bay trees in the southeast that are dying, and those trees are probably healthy in the spring, and by the summertime they may be dead. So you see where it is across the southeast. In the next few slides, I'm going to go through sort of how this beetle was first found and how it progressed across the country. So the first beetle was found in 2002 near the port of Savannah, Port Wentworth. And at the time, we didn't think it was anything special. It was just another Ambrosia beetle. There was no indication that this was an aggressive species or the fungus was aggressive. It certainly doesn't behave that way for the most part in its native country. We've come to learn that it may have some, the fungus may be somewhat pathogenic in its native country, but at the time we didn't know that. 2002, 2004, some dead and dying red bay started showing up around Savannah and Hilton Head, South Carolina, and little by little we realized that this beetle and the fungus and the dying red bays were showing up across the southeast. By 2005, they were showing up in Florida. It keeps spreading. Part of this was we started surveying for it more, but the beetle was also spreading. Certainly, human-assisted spread to Mississippi, probably human-assisted spread to southern parts of Florida, up to North Carolina. So I mentioned that this beetle likes members of the laurel family. Certainly, red bay is its major host, but it does attack other species in that family. And in southern Florida, they grow avocados. Avocado is the same genus as red bay, Persea. So it is affecting avocados in Florida. In other parts of Georgia and South Carolina and probably in Alabama, those infestations were in another species of laurel, the sassafras tree. And I think a lot of the spread in sort of interior Georgia and you'll see in Alabama and Mississippi and Louisiana, that is all in sassafras. And it continued to spread 15, 16, 17, it's just filling in all these areas across the southeast coast. What was probably the most surprise though was 2019, where it jumped up to Tennessee and Kentucky, where again, it's found in sassafras. So there's dead and dying sassafras up there. It doesn't seem to be as aggressive in sassafras, and it's not clear if that's because the tree is not as good a host. Maybe the tree is not quite as attractive as the red bay trees. It doesn't put out those chemicals that are attracting the beetles, or it's colder up there, but it doesn't seem to move as quickly as it did through the red bay forests of the southeast. Regardless, it is still impacting sassafras, and there's concern because sassafras is an important tree that goes up through the northeast, even to southern Canada. So again, a little bit of summary of red bay ambrosia beetle, attacks Lawraceae, a variety of hosts. How is it getting spread? Probably firewood, some of those big jumps up to Tennessee and Kentucky, most likely firewood. It is not really attracted to ethanol like other beetles, other ambrosia beetles. There's this alpha copain, which is sort of a host odor, especially in these laurel trees, that seems to be very attractive, and that's being used in traps to detect and survey for this beetle. As far as management goes, before I mention the female and male differences of some of these ambrosia beetles, so the males mate with usually the sisters of the brood of that female. So a female leaves, she's already mated, and she could start a new infestation right away. If she is not mated, she will lay eggs that turn into males, and she'll mate with those. So they are very good at establishing new infestations in areas where there may be no mates around, because she could just start a colony all by herself, an infestation. So that makes management a real challenge. You could get rid of a lot of the beetles. In fact, it was tried in some of those coastal islands in the southeast, trying to eliminate every red bay tree there is, cut down every infested tree. But they only miss a couple of beetles, and you're going to have an infestation again. So management's a real challenge, especially in the forested areas. You could protect landscape trees with insecticides and fungicides. Fungicides are, of course, important because you need to kill the fungus that's in those trees. But management in the native forest is much more of a challenge. Just going back to ethanol a little bit, just kind of a side, kind of an entertaining little side here is this beetle, the Nestis mutilatus, and you could guess why it gets its scientific name, mutilatus. Looks like the back end is cut off there. But it loves ethanol. And this picture, you may have seen a gas can, plastic gas can on the left side there. has gas has ethanol in it these days, and they just bored right through there, and they probably got a mouthful of gas once they got through the plastic, but just an indication of how much these beetles, especially this species, loves ethanol. So that's what's being used to survey for these beetles for the most part. Most Ambrosia beetles, like I said, are responsive to ethanol, so that's being used in these traps like you see on the right side there, these funnel traps. Okay, so I talked about the red bay ambrosia beetle in the southeast. Well, in California, there's a couple of other species that are causing problems also. The Polyphagus and the Corotio shot-hole borers. These look almost identical to each other. They're really, really hard to tell apart, but you can tell them apart by doing genetic analysis, but morphologically, they're quite a challenge. And for a while, they kind of went misdiagnosed. They were thought to be the tea shot-hole borer, which is a pest in Asia that, as its name implies, attacks tea, but also attacks a bunch of other species. These, the tea shot-hole borer, and these are all from Asia, and they all really similar, but they all attack and continue to attack pretty healthy trees. As the name implies, different from the red bay beetle, they are polyphagous. In Southern California, there's the Polyphagus shot-hole borer in the Los Angeles area. The Corotio is more down in San Diego and Tijuana, but they are starting to overlap. They do not interbreed. They are definitely good species, but they are causing quite a bit of problems in the native forests as well as landscape trees. Like I said, Polyphagus is their name, at least for one of them, but they are both polyphagous. This is just a small sampling of the number of trees that they have been found to attack. This picture on the right here is a riparian area in the Tijuana River, not too far from the Mexican border. In fact, it might be the wall back there, I'm not sure. But these beetles have pretty much wiped out these willow trees in this riparian area. So again, very aggressive, attacking pretty healthy trees. A little different, they don't carry a fungus that's very pathogenic, like the red bay beetle does, but they do carry a fungus with them, like all ambrosia beetles do. And that fungus helps the tree decline slowly. And these beetles keep repeatedly attacking the same tree until it's no longer suitable, which may be for several years. Again, these beetles don't respond to ethanol too much. They respond to a chemical that is, I'm not sure if it's a chemical that the fungus is producing, or it was first isolated from another ambrosia beetle in another part of this weevil family of ambrosia beetles, but it seems to be very attractive, and it's now being used to survey for these beetles to see where they are in California and other areas. So this is breaking news, another beetle. We're not done yet with new beetles. Just recently, in the past year or two, dying oaks were found in, they're called valley oaks in northern, or the Napa Valley of California. The beetles were collected in this valley oak on the left side here in late 2019. So this really is kind of breaking news. The beetles are identified right away, and they were found to be another new non-native species of ambrosia beetle. When surveys were done, people started looking around in California. They realized that this beetle is not new to the area. It's probably been here for quite a few years because it is well established, and some of these trees are really heavily attacked. So this is the first establishment of this beetle in North America, but it is not the first find of this beetle in North America. In 2018, a beetle was found in a trap in Portland, Oregon. One beetle was found in one trap, and when they tried to do surveys again in 2019, no additional beetles were found. So they thought, well, maybe it was just beetles coming off of a tree of a ship in the Portland area. I'll follow up on that in a minute, but finding these beetles in California was quite a surprise, especially that it's such a well-established population, as you can tell by the heavy attacks on these. So what is this beetle? It's Xylibris monographus, another ambrosia beetle. This one, though, is not native. Well, it may be native to Asia, at least Korea, but it's mostly a European species. And the people in California have given it the name the Mediterranean oak borer. And yes, that comes out to be mob. So they're fighting the mob. But it is not a problem in Europe. In fact, when I talked to colleagues there, they said, wow, it's really just a pretty minor beetle and never really attacks healthy trees. And we're not quite sure if it's attacking healthy trees here or stressed trees. But as in Europe, it does favor oak trees, and it seems to, I don't say be a pest, but is mostly attacking members of the oak family, which includes chestnut and beech. But for the most part, it is attacking oaks in Europe, and that's what it's attacking here, especially in parts of France and the Mediterranean area, where we're not sure where this beetle came from yet, if it came from France or other parts of Europe, or if in fact it did come from Korea, where it is found. But that's still to be determined. So where was it found in California? Well, it was found in Napa Valley, Calistoga. If you look down a little further south here, there's Napa, here's Sonoma. As I said, it's become apparent that it's probably been there for a number of years. There's infested trees probably in a 15-mile stretch north and south of Calistoga. They found some infested trees in Sonoma County. So what's going on there? Why is it in Napa? Well, we're not sure yet, but this is wine country, and did it come in on wine oak to make wine barrels? It's not clear yet. That's still being investigated. So where did it come from? We're not sure. What is its distribution? California they're doing surveys right now. I'll show another slide with that. How long has it been here? It's probably been here for at least 5, maybe even more than 10 years, based on its wide distribution and its heavy infestations in some of these trees. What are the impacts is the big question. Is it attacking healthy trees? Is it attacking stressed trees? California has been dealing with the drought. This beetle also seems to like fire stressed trees in Europe, and certainly California's had its issues with fire the past few years. So, is that setting up these trees for attack by the beetle? So California and the Forest Service and CDFA, Cal Ag and Cal Fire, UC Extension and the Forest Service, we're looking at doing surveys to figure out where it is. We're looking at evaluating the impacts of the beetles across the area. We're also looking to figure out if what's the best trap and lure. Is ethanol going to work for this, or are there some other oak odors that may be better tools to trap this beetle? And we're also kind of thinking back to Oregon. It was found in Portland, but is that an outlier? And if there's a connection to the wine industry and bringing oak in from other countries, maybe they should be doing some trapping in wine country of Oregon. So they'll be doing that in 2020. So why are there so many ambrosia beetles here, and where are they coming from? So ambrosia beetles, as we've been indicating, they're very cryptic. They live in the wood, not like bark beetles where they're living underneath the bark. Bark beetles are probably much more commonly intercepted at our ports because port inspectors could pull back the bark of a piece of wood, a piece of dunnage, wood packing material, and you could see the galleries and maybe even see the beetles underneath that bark. Ambrosia beetles are going right into the wood, so they're much more cryptic, much harder for inspectors to find. They're also prolificous, like I said, so they could come into this country and they don't have to look for a pine tree or a spruce tree or an elm or an ash. They just need to look for a tree, and they could start an infestation and feed on their fungus. They don't care what that species of tree is. And as I talked about before, and this picture indicates, one female can start an infestation by herself. She doesn't have to find a mate in a country or an area that there may only be 1 or 2 beetles of that same species introduced into that country. So they're much better at establishing. And finally, many of these species are coming from an area, Asia, where there's been increased trade over the past 20, 30 years. This is a graph of bark and ambrosia beetles. Again, I'm not talking about those seed infesting beetles, but just bark and ambrosia beetles. You see before 1900, there was only about 5 beetles, bark and ambrosia beetles, established in this country. And 4 of those are bark beetles. As time went on, there was not too much action between the 1900s and the 1980s, but then as trade picked up, you'll start to see that more and more are getting established, and more of those are Ambrosia beetles. To use the maybe overused phrase these days, maybe there's a flattening of the curve, and that may be due to better inspections, maybe better cooperation between countries. There's standards being implemented for better or worse, or being done somewhat well and somewhat not so well amongst the different countries, but there are some regulations in place that are being instituted that may help cut down the number of establishments. But again, talking about where these things are coming from with increased trade, all those things that are underlined, all these species underlined, as you see, are from Asia. They're all Ambrosia beetles, except for the more recent one, this Silabris monographus that's in California. We think that may have come from Europe, but for the most part, Ambrosia beetles are coming from Asia. The ones that are not underlined, those first two, those are bark beetles. They came from Europe. Sclydus cherryrui, one that halfway down on the left side there. That, I say Asia, it occurs across a good chunk of Asia, even the western parts of Asia in towards Europe. So again, increased trade with Asia, not just China, but other parts of Asia, Korea, Japan, Vietnam, some of the Southeast Asian countries, where a lot of these species occur. Remember, I said early on that there's quite a diversity of Ambrosia beetles in the tropics, old world especially. So that's nice. What can we do about this? Well, obviously the first line of defense has always been port inspections, stopping these things from coming in. But there's challenges there. Like I said, port inspections work somewhat well for bark beetles, for a challenge for Ambrosia beetles. The next line of defense has always been called early detection and rapid response, EDRR. And the Forest Service and USDA APHIS is doing trapping at ports and areas near ports, high-risk sites, to try and trap these beetles and kind of detect them early enough that we could do something before they become well established. That has worked somewhat well. There are some challenges with that. Bark beetles, again, are maybe easier because many of these bark beetles have pheromones that we could use that are much better at detecting bark beetles. Ambrosia beetles do not have pheromones. They're responding to host odors, like I said, ethanol, and that doesn't attract beetles as well as those pheromones. So EDRR, while it is a good effort, has posed some challenges. What we're looking at more and more often now is having a better idea of what the potential invaders are before they get here. Looking at trees that are maybe planted in Europe and Asia, North American trees, and identifying those native pests in those countries that could potentially impact those North American trees. These are called sentinel trees, where you plant, say, North American oaks or pines or elms in those countries in Europe and in Asia. And then we do the same here. We're planting some of those species in North America to see if there are North American species that could affect European or Asian trees, because I'm talking about things that are coming to the United States today, but we also give our share of pests to those other countries, to Europe and Asia. So there's cooperation between university researchers, states, and federal governments across Europe and Asia and North America to kind of look at that. What is the next thing that could potentially get introduced here? And then management. Management's been a challenge, certainly. As I said, you could treat some of these trees with insecticides. You can't, these beetles are going right into the bark and into the wood of the tree. So it's not like you're going to spray a tree from the air like you do, say, a gypsy moth or something. You have to usually inject these trees with an insecticide. And that presents a problem if you're trying to talk about a whole landscape, like that landscape of the riparian areas in Southern California with all those dying willows. In landscape ornamental trees, yeah, they could probably be managed with insecticide injections and fungicide injections, but in the landscape, it's always been a challenge. So hopefully, I gave you guys an idea of what's here, what their impacts are. Somewhat not the best note to end on about the challenges of stopping these beetles, but hopefully you've got that last slide, I'm bothered because that beetle was supposed to fly in and kill that tree. But anyway, hopefully there's some questions that were generated, and I'll turn it back over to you, Belle, for some questions.
Fantastic. Thanks, Bob, for that excellent presentation. We do have a lot of questions, so we'll try to get through as many as we can. This one comes from Thomas Macy. Yeah. And if we can't get to all of them, we'll download the questions and send them over to Bob, and he can respond directly. Or you've got his contact info there. You're welcome to reach out to Bob directly. So the first question comes from Thomas Macy. He says, because the bark beetle galleries are larger and seem to impact more of the phloem, are they usually more damaging to their hosts? It doesn't look like ambrosia beetles would compromise the vascular tissue all that much unless it's a mass attack.
Yep, you're right, Tom. That's exactly the case. The bark beetles feeding under that bark in the phloem cambial area have a much more, say, immediate impact when they also mass attack trees. Some of the more aggressive ones attacking healthy trees. Some of them also carry a fungus, which helps them overcome any tree resistance. So yeah, ambrosia beetles require, unless it's like the red bay ambrosia beetle where it's carrying a fungus that's very pathogenic, you do need more beetles. That example I showed with the granulate ambrosia beetle with all those frass tubes coming out, that tree is pretty much being mass attacked. So the little fungus introduction that occurs around there, you might start seeing some dieback of the phloem cambial area. But in general, yeah, ambrosia beetles are not quite as damaging since they're going into the wood as a bark beetle would be. Hope that answers your question, Tom.
Mm-hmm. Great. All right, next question from Karen Rain. Are non-native ambrosia beetles involved in the recent widespread decline and death of oaks in the mid-Atlantic region?
Thanks, Karen. Yeah, you should know about all those oaks that are dying in the mid-Atlantic. That is a question that we are still trying to answer. For those of you not in the mid-Atlantic, there's been a lot of dying white oak trees, especially white oaks, but some other species of oaks in the suburban DC, Maryland, I think even in Pennsylvania, Northern Virginia area. And we're not sure what's causing that. Is it that, we've had a couple of wet years a few years ago, and then some dry times in the past, like last summer? Were those trees stressed? Is there some root pathogen like a Phytophthora cinnamomum that's taken advantage of those stressed trees? Or is there some ambrosia beetle or some group of ambrosia beetles that are attacking those trees? Certainly the folks in Maryland, DC, I think Pennsylvania are looking into that. I know the folks in Maryland are putting up some traps to see if there are some ambrosia beetles in those areas with the dying white oaks. But yeah, that's a question that we still need to answer, and hopefully we get an answer soon. And hopefully it's not something new and damaging. Not that Phytophthora cinnamomum is not a serious pest, but hopefully not a new ambrosia beetle.
Great. We've got a lot of great questions. Next one comes from William Vitaliano, who asks, have there been any advances in management of Scoletus, I'm sorry if I'm mispronouncing, Scoletus multistriatus, and at how many growing degree days do we expect them to become active?
The last part, I'm not sure if about degree days. I know in the DC area, that first generation, they overwinter as larvae. That first generation matures to adults and starts flying probably in mid to early May. There are multiple generations. I think in DC, there's probably 3 generations a year. As you go further north, when I did my graduate work with elm bark beetles in Syracuse, there was probably 2, maybe an occasional 3rd if it's a warm fall. So yeah, they start to emerge probably in May. I'm not sure what the degree day count would be. As far as new management techniques, management of Dutch elm disease and elm bark beetles is really dependent upon good scouting, trimming those trees that show any sort of signs of flagging in trees. Elm bark beetles feed in the twigs of healthy trees, and you'll see the disease progress from that twig down through the branch. So identifying that right away, pruning out that diseased limb is a good first step. Injecting those trees with insecticide or actually fungicide is the next part of the management plan. And that's what's been done. If you go in the mall in DC, between the Capitol and the Washington Monument, there are still hundreds of healthy elms there. And on the city streets of Washington, DC, still hundreds of elms. That's because they do some serious scouting. Like I said, looking for diseased limbs or twigs and branches, pruning those out, and then doing injections and removing any dead, dying trees before the beetles could spread to other healthy trees. That's not new. I mean, that's been kind of the way it's been done for the past 10, 20, 30 years. So hopefully that answered that question.
Great, thank you. Yes, I have a question here from Melanie Broadhead, and I'm going to paraphrase this a little bit. Her question is about the red bay ambrosia beetle. She's been working in Central Florida land management for over 10 years and has observed that they do not have management issues currently, and the red bay seem to have naturally overcome this infestation. In your opinion, do you agree that the red bay ambrosia is not a threat any longer because the red bay is able to reestablish?
Well, I've never heard that they're reestablishing. I know some areas the red bay is seeded in, and some of those small trees are coming back. But from what I had heard in some of the other areas, not so much Central Florida, but some other areas where those trees, once they get to be a decent size, they are being attacked again. And the beetle most likely didn't disappear. I mean, maybe in some areas it did kind of disappear, but that's not something I've heard before. That would be very interesting to see. And certainly the folks in Florida, Department of Forestry, would be interested in checking that out, I'm sure. But I mean, healthy trees, I wouldn't even say they could overcome an infection. They might be able to overcome an attack by an ambrosia beetle if it's not carrying that pathogenic fungus. But yeah, that would be interesting to see. I'm sure people in Florida would be willing to check that out.
Mm-hmm. Yeah, definitely. Okay, next question is from David Cox, who asks, what packaging material or sources are common for exotic species, and what is being done to address this source? Is this an issue in lumber yards of native areas or becoming infested as a pallet per se?
Yeah, I mean, dunnage and wood packing material coming in from other countries is the main way these things are getting introduced. You know, it may be that a piece of machinery, a tractor or some, other hard machinery, or even tiles and granite and marble are getting shipped across the world, and wood packing material is used to stabilize that shipment. Maybe it's used to brace up, the machinery, or is surrounding the tiles and something like that. So that wood, although the inspectors may not think that there is wood in there, since the manifest may say tile or machinery, may be carrying those beetles. So I think that's the main way things are getting introduced. Wood products are a possible way, but I think regulations now that they're supposed to be free of bark and treated. Even the wood pallets are being treated. That dunnage has to be stamped that it's been either heat treated or fumigated some way, and that is being done to maybe not as well as it should be. So some things I'm sure are slipping through. But as far as lumber yards and stuff in the United States, probably not a real pathway, although I guess it is possible for local movement, say, moving some infested lumber from one part of a state to another. And again, these ambrosia beetles may be better at that, establishing in a new area than others. But I think the main pathway is that wood packing material. As far as pallets go, I think pallets, if they're dried out and they don't have any bark on them, they're probably not great. I don't think pathways, although they could be if they're fresh and they're green and there are beetles in there. They certainly could possibly be a pathway, but less so than say just solid wood packing material such as tonnage and bracing.
Great. All right, we've got time for a couple more questions. This one is from Gwen Berzicki, who asks, are there biocontrol opportunities for non-native beetles that are established and are proving to be pests?
Yeah, biocontrol for wood borers in general has been a challenge, especially for some of these species that are so cryptic. They looked at biocontrol for elm bark beetles when they were first found here, Dutch elm disease, in the earlier part of the last century, or the middle of the last century, and they never really worked out too well. Biocontrol for Ambrosia beetles, that's been looked at, especially for the shot-hole borers that are in California, but that's been a challenge. To find a host-specific biocontrol agent is going to be really tough to find, I think. Now, when I'm saying that, I'm talking about parasitoids like parasitic wasps and those sort of things. Are there possibilities for pathogenic fungi? Yeah, maybe, but again, the same challenge may be host-specific. There's lots of native ambrosia beetles and bark beetles here that you don't want a biocontrol agent to impact. So you have to be careful, and we don't want to introduce something that may be worse than, cause other problems across the country. So it's being looked at. It's a challenge with wood borers. Most of the time, wood borers, the ecology is that host resistance is the main thing limiting even native bark and ambrosia beetles, or certainly native bark beetles like southern pine beetle or western bark beetles. It's really host resistance or lack of host resistance that these beetles take advantage of, and biocontrol may play a part, but not a major part in their control.
Great. Okay, we got time for one more question from Joey Caputo, who asks, could drought compound pine shoot beetle impacts on native forests? And I kind of want to expand on that. Could drought compound, I think, the spread of any of these ambrosia beetles?
Yeah, the first part first, with the pine shoot beetle. In Canada years ago, probably a good 20 plus years ago, they did see pine shoot beetle causing some problems in a pine stand. And in Europe, the reason pine shoot beetle kind of got a lot of attention here is because in Europe, it does cause some problems in pine stands, especially pine stands that are stressed. But it is not a real aggressive species. So yes, I suppose if there's drought stress, those beetles can take advantage, as most bark beetles do, take advantage of those drought stress trees. In general, I guess, Belle, your question about is it helping the spread of these beetles? Possibly. I mean, again, maybe that's what's going on in California. The drought there led to all these drought stress trees, and the beetles have taken advantage of that and spread across that area, Napa County and nearby counties. That's a possibility. But a lot of these beetles do occur in the southeast, and there are certainly droughts there. Quite often the humid conditions also favors these ambrosia beetles. So I guess the answer is yes and no, and it depends. As researchers always like to end their presentations with, more research is needed on that.
Perfect. Yes, there's always questions that come up, and more questions that need to be answered. With that, I'm going to thank Bob Rabaglia again for his excellent presentation today, and I want to thank everyone for joining us, taking time out of your busy your busy days to join us. And I want to wrap up by saying that this webinar was presented with the support and organization of the North American Invasive Species Management Association. The NASMA organization is supported by its members. So if you are not a member today, please hop over to our website and check us out. We have a variety of options to support us as an individual or an organization. So check us out. And I also wanted to say that this webinar is recorded and will be available on YouTube for a period of time through this month. And then it will be accessible to our members after the end of April. And beyond that, we are going to send everyone a certificate for attending today. You're welcome to use that for CEU credits for those who need that. And with that, we will wrap up. And again, thanks, Bob, for this excellent presentation. This has been really informative and useful for myself, and I'm sure for many of those who joined us today. So thanks again, and have a great week, and we'll see you on the next webinar.
Thank you, Bill.
All right, take care.